Hello everyone, so today I'm going to solve this paper D problem for Seamo X 2024. So number one, find the remainder when 2024 power of 2024 is divided by 7. So here I'm going to use a modulo. So I will write it as 2024 power of 2024 modulo 7. So if you don't understand about modulo, I already put the link below about modulo introduction, so you can go there and then learn about this one. So for modulo itself, so if we have problem like this, we can first simplify this base number 2024 with 7. So 2024 modulo 7. So what is this modulo function do is that it will find the remainder for 2024 when it's divided by 7. So here we got 2, 14, and then 6, 62. So we have 8, 56, 6, 64, and then 9, 63, and then the remainder is 1. So it means that 2024, when we modulo it with 7, the result is 1 as remainder 2024 modulo 7. So 1 part of 2024 is 1. So 1 modulo 7 is 1. Next one is for number 2. Okay, so I have this triangle here. So we have the triangle ABC where AB is 3. So this one is 3. And then the BC is 4. And then the AC is 5. So this must be A, this one is C, and then this one is B. So this is the angle A. Okay. Given that sin to A, so sinus to A is equals to x over y, where x and y are co-prime. It means that x and y cannot be simplified any further. So find the value of x plus y. So for this one, all we need is that we need to, because we already have this triangle here, so now we need to expand this sin to A. So for expand sin to A, then you need to memorizing the formula. The sin to A can be expressed as 2 times sin A times cosine A. So now we need to find out what is sin A and what is cos A. And since we already have this triangle, so then it's easy for find sin A. So this is the angle A, right? So sin A will be 4 over 5. And then the cosine A will be 3 over 5. So with that, then we can calculate this one. So this one will become 2 times 4 over 5 times 3 over 5. So here we will get 24 over 25. So since to A is x over y, then x over y is 24 over 25, and then we need to check whether this 24 and 25 cannot be simplified, and in this case cannot because both of them already co-prime. So it means that the value of x is 24 and then the value of y is 25. So x plus y will be 49. Next, for number 3. So here for number 3, find the remainder when x power of 3 plus 3x power of 2 plus 2x plus 1 is divided by x minus 2. So for this one, we can use two methods. So the first one is that I'm going to use the remainder theorem. So I'll put the link below about this remainder theorem if you interest to want to know more about the remainder theorem, because the one that we have here is actually is very simple one. So the remainder theorem is that we can use this x minus 2 equals to 0. So this x minus 2 is actually the divisor. So it means that we will have x equals to 2. So with this one, we can now write down again the function fx equals to x power of 3 plus 3x power of 2 plus 2x plus 1. So since here the x equals to 2, then we can calculate the remainder when x equals to 2. So f2 will be equals to 2 power of 3 plus 3 times 2 power of 2 plus 2 times 2 plus 1. So here 8 plus 12 plus 4 plus 1 is 5. So the answer is 25. If you're not sure about this one, we can use the simple one, which is long division. So this is the second way how to solve this one. Okay, long division. So we just put here x power of 3 plus 3x power of 2 plus 2x plus 1 divided by x minus 2. So for this long division, remember that you need to eliminate the first term first. So in this case, we have to eliminate x power of 3 first. So this x, we need to multiply by x power of 2. So x times x power of 2 is x power of 3 minus 2 times x power of 2 is 2x power of 2. And then we can repeat it until we have the remainder. So this one will become 5x squared plus 2x. Same thing, 5x squared need to be eliminated first. So here I will plus 5x. So 5x times x is 5x squared minus 10x, right? 5x times minus 2. So here we got 12x. And then the last one, we put 1 there. So again, plus 12. So 12 times x is 12x. 12 times minus 2 is minus 24. So we got the result at the end is 25. So this 25 is the remainder. If you're using long division, same thing. If you're using the remainder theorem, we will get 25. So the question is why using remainder theorem rather than long division. So in this case, we can use long division for sure because the problem is still basic. But if we face with more complicated one, remainder theorem is actually more useful than long division. The next one is that evaluate this one. So you can see here, we already see the pattern, right? So the pattern is that this number 2 here, always up 2 power of 2 and then double again 2 power of 4 and then double 2 power of 8 until 2 power of 256 and always plus with 1. So what we're going to do that this one is more like a 3 question. So since I can put 1 in front of 2 plus 1 times 2 power of 2 plus 1 until 2 power of 256 plus 1. Okay, so this one here I will change to become 2 minus 1 because same thing, right? 1 will change to 2 minus 1 until 200 and power of 256 plus 1. So why we're using 2 minus 1? Because remember that we have this expansion when a minus b times a plus b, the result is a square minus b square, right? So same thing with this one. If we multiply these two, we will get 2 power of 2 minus 1 power of 2, or I just simply put it as minus 1. And then this will become like telescopic. And then I will operate 2 minus 1, 2 power of 2 minus 1 minus 1 with 2 power of 2 plus 1. So we will get, so I'll write it again. Okay, we already operated with this one. So from here we will get 2 power of 4 minus 1. And then same thing, we will continue until 2 power of 256 plus 1. So I'll make it short. So at the end we will get 200 power of 256 minus 1 multiplied by this one, the last one, 2 power of 256 plus 1. So we will get 2 power of 512 minus 1. So if we put it here, then we will get 256, 2 power 512 minus 1. And don't forget the last one, we got plus 1 here. So these two will be cancelled out. So what we got is 2 power of 512 divided by 256. So we will get, the answer is 2 power of 2 or 4. The next one, number 5, find the least value of. So first one is that I can write this one as log 100 of a power of 2. So I already move these 2 here, becomes a power of 2, and then minus it with log a of, this one is, so it will become 1 over 10 power of 4. So from here, again, log 100 of a power of 2 minus, this one is log a of 10 power of minus 4. Now we'll write it as log a power of 2 divided by log 100 minus, this one will become log 10 minus 4 divided by log a. So you can see here that this 100 here, I can change it to become 10 power of 2. So it means that these two will be cancelled out, right? Or I can write it as 2 times log a divided by 2 times log 10 minus, so this minus 4, we can move it here, so it will become plus 4 log 10 divided by log a. So our final result is log a over log 10 plus 4 times log 10 divided by log a. So what is the question? The question is find the least value. So now I will simplify this one by using, so let's say x will be equals to log a over log 10. So then you can change this one become x plus 4 over x. Okay, so to find the maximum value of this one, I will using AM GM inequalities. So this one will become x plus 4 over x over 2 bigger or equals to square root of x times 4 over x. So here we got x plus 4 over x. So this x and x will be cancelled out. Square root of 4 is 2. And then same thing, I will move this 2 to this one or to this side. So 2 times 2 is 4. So I will have x plus 4 over x is bigger or equals to 4. So if they're asking about the least value or minimum value, then the minimum value is 4, right? Because x plus 4 over x, the minimum is 4, and then after that, because this one is bigger or equals to 4, so the minimum is 4.